Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello guys, welcome to the Pytorch tutorial series. Today's topic is logistic regression using Pytorch. To implement logistic regression in Pytorch, we are importing torch, torch.nn, torchvision.transform.functional.ftf just in case we have to normalize, torch.autograd, numpy, and pandas because we are handling some CSV files. So today we are using a very nice dataset that is taken from kaggle.com. You can use this link to download the dataset. It's called PIMA Indian Diabetes Dataset. You can find the dataset and read about it here on Kaggle. It says predict the onset of diabetes based on diagnostic measures. You can read about the predictive variables that are given and explained in details on their website. Here I have uploaded my dataset here in Google Colab, and I am using that CSV file in today's project. The first thing we have to do is we have to read CSV file, and when we do that, it looks a bit like this. So as you can see, the column names have been edited to 0 to 8. But if you want to read about the descriptions, you can read it right here. Column 0 means number of pregnancies. Column 1 means plasma glucose concentration at 2 hours in an oral glucose tolerance test, and so on. I have listed them out here also so that you have the idea of the dataset. The last column, column number 8, is for 0 or 1, and it tells you whether a person has diabetes or not. So logistic regression is being used in today's project, and as you can see, it's a supervised machine learning algorithm for classification. So let's do some preliminary work on our dataset. First, we have to check how many data points do we have. It says the shape of the data frame is 768 by 9. Of course, the 9 is for the number of columns, and we have 758 examples or data points. So I'm taking 70% of them for training and 30% of them for test. Like that, I create X train and Y train. Basically, X train has the column 0 to 7 that are predictive variable, and 8 is the classification. So Y train has all the labels. Similarly, I create the test set that has X test columns 0 to 7, and Y test has the column number 8, which is basically the labels of all the data points. So first thing we are doing is we are converting our data frames into tensors, because like I mentioned in earlier videos that Pytorch works with tensors only. One thing here to notice is that I'm converting the X underscore train to float, X underscore test to float, and since the labels are basically integer numbers, I'm keeping them as long. So make sure that you're using right data type for conversion. So now the X train and X test look like this. And one thing here to remember is that you have to reshape Y train and Y test so that the shapes look like this. Okay, let's define our logistic regression model class. Give a meaningful name. I have given it a name, logistic regression model. Make sure you inherit nm.module inside it. First thing is to define an init function, and inside the init function you have to call the super that calls itself. And since in today's project we have 8 predictive variables and 2 possible outcomes, we are keeping the input dimension as 8 and output dimension as 2. So self.linear is equal to nn.linear input dimension, output dimension. Since logistic regression doesn't need any activation state, we are not using any activation functions. So the forward pass only has the linear function that is being implemented on the x values, and we are returning itself. Next thing we have to do is instantiate the logistic regression model class with proper variables as argument passed into it, input dimension and output dimension. We are passing our model to CUDA so that we can use GPU. We are using cross entropy loss as a loss function. You might remember in the last video for linear regression, I used MSE loss. Today I'm using cross entropy loss, which uses basically a softmax function to assign probabilities to each of the possible cases. And we will take the case that has the maximum probability. So cross entropy loss is also a good loss function for classification task. I would have also taken BCE loss. This is also a good function, just to give you a pointer. We are choosing 1000 epochs. You can choose anything that is suitable for your project. The learning rate has been set to 0.001. Optimizer is SGD, which means stochastic gradient descent. And with that, we are ready to train our model. Inside the training, we are using CUDA to convert our training inputs and training labels into train underscore inputs and true underscore train. Optimizer.0 underscore grad initializes the gradients at each pass. Train outputs are basically predicted labels on the training dataset, and after that we calculate our loss, and loss.backward basically calculates the backward propagation. Optimizer.step updates the weights and biases, and after that, after each 50 epoch, we are checking how our model is working on our test set. So inside the test set, we are doing test underscore inputs equals to variable x underscore test dot CUDA, which is basically converting our test inputs into variables. The outputs are predicted on test inputs. The predicted values are gathered from torch.max, which basically takes the maximum probability, the label that has the maximum probability. We calculate how many of the total variables are there, the total number of data points in the dataset, which is 231 in our case, and we check how many of them are correct, and from that we calculate our accuracy as percentage of correct by total, and we print our total accuracies and total losses, and when we plot them, it looks something like this. So the accuracy is almost at around 65%, which is not bad given the fact that we didn't do any feature engineering on the dataset. If you normalize and standardize your dataset and you use better hyperparameter tuning, as in increased number of epochs or better loss function and better optimizers, you might achieve a higher accuracy rate. Thanks for watching.